Hey guys, welcome back to Python the Right Way. I'm Ian, and I'll be teaching you some more stuff about Python today. So, the topic of today's video is data types. What are they? Well, a data type is basically a thing that describes any object or thing in Python. So, we already talked about this a lot in the first episode. We'll just run through them pretty quickly. An example of a string object, that's what str stands for, would be like x equals to hello, okay? This right here is a string. We print out x, we get hello. If we print out the type of x, we get class string. So that's what it's saying. It's saying this is a string. So we're not going to do that for all of them. We're going to run through these real quickly. Ints or integers, those are just regular numbers, how most people think of them, just 231. There's an integer. Floats are numbers that include a decimal point in them. So for instance, 14.5. And just to go over it really quickly, if we print the type of y, we'll see that it's an int. But if we print the type of y plus z, we'll see that that's a float. Why? Well, because when we add y plus z, you see 14.5 gets added to 231. So it has a decimal now, so it's a float. So certain data types will conform to other data types based off how you try and add them. So down here you can see the full list of data types in Python: lists, tuples, ranges, dictionaries, sets, frozen sets, booleans, bytes, byte arrays, memory views, and none types. That's all of them. Now there will be a lot of other data types added through different kind of modules of Python. We'll learn about those later. They're called libraries. But you don't need to worry about that for now, and you don't even have to worry about these for now. Just kind of giving you a peek ahead. I mean, some of these we aren't even going to touch in this course. Like, I have never used a memory view before. So, yeah, really the most important data types that you'll have to learn about are lists, tuples, ranges, dictionaries, bools, and none type. These are really the only ones that come up commonly. So we'll talk about those as they come up later on, but just for now, kind of think a data type describes the properties that a certain type of data has. So now we're going to go and learn about operations. So we just saw one operation, y plus z. That works exactly how you'd expect. The plus sign works exactly how you'd expect. So what if we want to do y minus z? Well, same thing, just works exactly how you'd expect. It's just subtracting one value for another. And again, if we try and do this with a string or another data type that this isn't applicable for, what we're going to get is type error, unsupported operand for types string and float. So that's a pretty common error you'll come up to a lot, is you'll realize, oh, these things aren't the same data type. If I want to, add them in some way, I'll have to use some other method. So like string concatenation, x comma z, and now we see hello 14.5. So yeah, sometimes you'll have to use special methods if you want to do certain things. So let's go back to here. We'll y and z again. What does the asterisk do? The asterisk multiplies it. So it's 14 and a half times 231.5. So what does this do? Well, this is like the division sign that you learned in math class. So it is 231 divided by 14.5 gets us 15.93. So this is the division operator. That's what this is called. And what's this thing called? Well, you might know this thing as the percent sign. That's pretty much how it's known and commonly used. But in Python, it's slightly different. In Python, the percent sign that you see here, we call this modulo. And what modulo does is it basically, if you remember math class, long division, probably way far in the past for you, but if you learned long division at some point, I'm terrible at long division. You couldn't ask me to do it now, but if you just remember when you did long division, you got the remainder on the right side of your divisor sign. That remainder, that's basically what modulo gives us. So it's going to divide y by z, and then it's going to tell us what the remainder is. So it's going to divide 231 over 14.5, and apparently that has a remainder of 13.5, right? So we can actually see, I was going to go to this one, but actually we'll skip over to this one real quick. This is what's called a floor divisor operator. So we have y, floor divisor, z. And what that gives us is it gives us the amount rounded down, right? So so basically when you divide two numbers, if one number doesn't cleanly go into the other one and you get a remainder, then when that's done by a computer, that'll present to us as, you know, all of these numbers. So everything after 15, that's what it's saying, right? 14.5 goes into 231 15 times, but if you tried to add a 16th to it, you would have more than 231. So how much more than 231? Well, 0.93 of 14.5. So 93% of 14.5 goes into 2.31. So, or 231. I'm sorry, I can't talk today. So, if we look at this, we'll see that the remainder is 13.5. And if we look at this, then we see that the remainder is 15. So, 14.5 goes into 231 15 times with a remainder of 13.5. And we can see that here, if we go here, 15.931. Well, 13.5 sounds like that's about 93.1% of 14.5. So that makes sense. We have our floor divisor, which gives us 15, and we see that 15 is the base number for the full division. So why would we use this? Well, floor divisor in particular is really useful whenever you're dividing objects that really only can represent one thing. You can't have a fractional amount of it, but you might still have data that's in a fractional form. So like, you can't have 13.2 apples, right? You can only have 13 apples if you're like a apple salesman or something. So this is going to give us that number that we can round down to and safely assume that's how many, you know, actually exist in reality. So now if we move past this, we can get to the double star. And what this is basically exponentiation. So if you remember from math class, you had like, 2 raised to the second power equals 4. 2 raised to the third power equals 8. Well, in Python, it's the same thing, just instead of using the like up caret here, we use 2 asterisks. So that basically you can think of it as like an advanced form of multiplication. So let's do a slightly simpler example. Let's do like 2 raised to the 2, we get 4 raised to the 3, we get 8 raised to the 4, we get 16. So yeah, just exponentiation. And now we're just going to look at a few more types of operators. So the first type of operator that we'll look at after this, you're well aware of, it's the equal sign. We haven't really talked about variables that much, but I think you've probably got an intuitive sense that this x right here is a variable, and it refers to this string, hello. So right now it applies to this string, but what happens if we go down here and say x equals to goodbye, what do you think it's going to print? Is it going to print hello or goodbye? Well, if we put print here, we will see that it prints goodbye. But what happens if we take this print right here and we put it like up here, like above this x? Well, it prints hello. That's because when a Python program executes, it runs each line sequentially. So it looks at line 1. It says, what's going on in line 1? Well, it's just a comment, so skip. So line 2, blank, skip. Line 3, blank. Line 4, blank. Line 5, comment. Line 6. Okay, we see this x. We know that x is going to be a variable because there's nothing before it, and it's just a letter or a series of letters, and then an equal sign that tells it that it's a variable, and then what it's getting set equal to, right? So because of that, x is now equal to hello in what is called the namespace of the Python program. You can just think of the namespace as all of the variables. Just what are all of the variables? If you printed out every variable and you printed out everything else like that, that would be the namespace. So if we go down here, we see that when we print x, it gives us hello because in the namespace, x is still hello. But if we go here and we print it, it says goodbye because the equal sign assigns variables values inside of the namespace. So right, this is the value, this is the variable, and this is how we're assigning it. So try to remember this. I know I'm explaining in a lot of detail something that probably seems pretty simple and that you've probably already picked up on, but going forward, remembering fundamentals like this will be very important as we learn that there are actually a lot of different ways to do something like this, and not all of them are exactly the same thing. They have subtle differences. So after that, we can talk about these operators. So plus equals. And so what these operators do is they basically shorten. They give us a shorthand. So let's say that we have z, right, which is equal to whatever, and we want to change what it's equal to. But we want to change it to what it's equal to in like relative to itself. So say z is a value on like a scoreboard in a video game, and we want z to increase by 1 every time that the player jumps to a new level on a hotel or whatever. It's like one of those doodle jump games. So if we did that the long way, it would be z equals to z plus 1. And then we would print z, and we would see that z is now equal to 15.5. Well, starting out it was 14.5, but now the player has gone up a floor, so now it's 15.5. But what this operator right here does, this plus equals, what it does is it basically just gives us a shorthand for this. So instead of z equals z plus 1, we can just say z plus equals, and we'll do 2 this time just for the sake of illustration. And we can see that now it's 16.5. Z plus equals z. What'll that do? Well, it'll double it, so it'll be 29.0. And we can use other operators on the right side of this one. So like z times 2. Well, now we're adding 3 z's to it, or we're adding 3 z's together. So now it's 43.5. Or we can do z squared. Now it's 224. Or we can do z plus y, 260. So that's all that this operator is doing. And I won't bother going through and doing the rest of these because they act exactly how you'd expect. So this one sets it equal to itself minus a certain amount. This one sets it equal to itself divided by whatever's on the right side, right? So let's say, let's do this one again, right? So let's clear these out. Z equals z, or z equals z over 2, right? and we print z. So that's telling us what what z divided by 2, what that would be without any remainder, so just a whole round number. Well, we get that, and we get the exact same thing if we just do this. So z equals floor divisor equals 2. So we're going to get the same thing. We're going to get 7.0, right? So it's saying z floor divided itself by, z is equal to itself floor divided by the value on the right here. And the exact same thing for exponentiation. So it's z exponented to the power of whatever is on the right side of the operator. So yeah, that's it for today's episode. If you have any questions, post them down in the comments. I promise that I will answer each and every single one. And let me know if there's anything you want me to change about this series, if there's any way I could make this better for you guys. And yeah, I'll see you guys in the next episode.